Hello, and for those who watched the first part of this video, the intermediate stuff, welcome back. And for those who didn't, hello. So, the higher section is, yeah, here we go. The A and A star stuff, right, the second half of our paper, okay, is where we'll see some of these things coming in, I guess. There's a lot more in this. This could be a slightly longer video. You might have a fair old watcher, so settle in, get comfy, get the popcorn ready, okay? So, I'm going to say a couple of things about indices first of all, right? We know if we times, we add indices, divide, right? A couple of ones that are not so common, okay? If we had something like this, right? We'd square the 3 and square, so both, basically everything gets squared. If that was, I don't know, just to say, if it was 3x to the power 2, and I add the power 3, I'm making a right mess of this, 3, right? I cube the 3, but basically I'm cubing the x squared, right? So I'd have to times those just for you to be aware, so that would become 6, okay? The other thing with indices that I've seen a couple of times recently is where little 1 markers, and they look like you've got a lot of work to do, right? But something like this, and it looks like, wow, this is going to take me forever, right? What even are they asking? But it's an indices question. It's only a 1 marker, so be careful. If it's a 1 marker, it normally means something simple has to be done. Okay, so it's a bracket to the power 7 divided by the same bracket to the power 4. So all that needed to happen there is to say, well, because I'm dividing the same thing, even though it's a bracket, I'm going to take away the little numbers, okay? The more higher tier stuff, though, is this. The bottom number of the fraction is the root. If it's 2, it's square root, but in this case, it's cube root. Separate all your workings out. Take your answer and put this number as the power. The power. So we've got the flower, power, and the root, okay? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then worry about any minuses, which take your answer to 1 over. So 3 parts to your answer, okay? The root, the power, the reciprocal, okay? So reciprocal meaning flip or 1 over. Here, you write the number, okay? You take away any number that isn't recurring, right? If it was the 5 and the 1 not recurring, I'd be taking away 51, but here I'm only taking away 5. And you divide by 9s and 0s. Every recurring number gets a 9, first of all. So 9, that's a 9, that's a 9. That one not being recurring gets a 0. So my answer here is 507 over 990. Again, I'm going to mention something here. I have seen this. I've seen 1/3 plus, I don't know, 0.59 with a dot there. Any site of a recurring decimal, change it to a fraction. So this would become 1/3 plus 59 take away 5 is 54 over 90. Okay, then, right, and I'm sorry we didn't include one of these, and I think there is one in your booklet, but right, to add fractions, the bottoms would need to be the same. So we can times that by 30 and times that by 30 to make the bottom numbers the same. So that would become 84 over 90. But it starts by realizing, oh, this is a recurring decimal. Mr. Lear said, if I see a recurring decimal in this exam, even if it's part of something else, I should change it to a fraction using his method. Okay? Surds and rational irrational numbers, right? Fg is f times g. F times g, which is the square root of 10. Okay, so square root of 10 plus h, which is also the square root of 10. Yeah, let's not start thinking there's anything can be done here. Adding and taking away is simplifying. It's just bringing things together. We talked about elephants today. An elephant plus an elephant. I've got 2 elephants. Nothing more I can do there. Here, fg again. We know is that from there. Okay, but we're dividing by this. Now we can divide and times as long as we leave the answer inside the square root. So 10 divided by 10 is 1. But the square root of 1 is 1. F times h. F is 2, h is 10, both in square roots, so that would be 20. But I have noticed it says simplify as well. So whereas 1 can't be simplified, the square root of 10, there's no real reason to break up 10. The only split of 10 would be 5 times 2, and neither of those have square roots. But 20 can be split 4 times 5, which is simpler because one of those does have a square root. Okay? Now, the question which I didn't notice today, I never said, says, then say whether the answer is rational or irrational. Anything with a square root left in it is irrational. So that one and that one. Anything that becomes a number is rational. Again, simplify, so we need to split it up, right? I'm going for 144 times 2, and the reason I am is because 144 is a big number that has a square root, and 2 can't be split up anymore. So look for something times 2, or something times 3, or maybe something times 5, right? Where the first one then has a square root. That's how to simplify. Okay, depends how many of these there are, right? It's how many times we have to multiply that together, I guess. If there's 6, 4, 5, 6, the first 2 will multiply to become 3. That's a kind of like special rule because they're the same indices. They'll become 3, and they'll become 3. So it's 3 times 3 times 3, which is 27. That's rational, if they asked. Okay. This foil, it's a number times a number. That's great. That's a number times elephants, or a number times a third. Minus 2 elephants, or minus 2 square root of 2. That's a number times a number of elephants, so 5 lots of 3 elephants, so it's plus 15 elephants. Alright, and no elephants, it's just, I don't even know where elephants came from, but there we are. And the last one, probably the hardest one, and the one that you needed most explanation, right? A plus times a minus, first of all, is minus. I got a 3, but I got no number to times it by, but I have got a square root of 2 times in a square root of 2. So if it was just square root of 2 times square root of 2, the answer would be 2. But because we've also got a times 3 in there, we need to times that by 3 to get 6. Simplified, I can collect numbers together. That's 4, 10, take away 6. Then I can collect elephants together. 15 elephants, take away 2 elephants. Leave me with 13 elephants. Please don't write elephants. Okay. Oh, and if it asked, that's irrational because it's still got a square root in the answer. Write down a value of x for which that is rational. In other words, right, so say x, I went with 11, right, as x. The bottom number means square root. Well, 11 doesn't have a square root. We then have to cube it, which is square root of 11 times square root of 11 times square root of 11. They would make 11, but I'd still have another one on the end. So that's irrational, so 11 hasn't worked. But hopefully you can see, right, the reason it hasn't worked is because 11 didn't have a square root. Whereas if I'd gone with 9, the square root would have been 3, 3 cubed would have been 27, and the answer would have been rational. So any number with a square root here will give you a number answer, which is rational. So I'm going for the answer 9. I would accept 1, 4, 9, 16, 25, 36, so on. If you see a bracket squared, please do write it twice and then expand. So don't just square both the things because there's more to it than just squaring both the things, okay? 5 times 5 is 25, then minus 5 elephants, then the outers minus another 5 elephants, and then minus times a minus is a plus, and square root of 2 times square root of 2 is 2. Collect the numbers, minus 5 elephants, take away another 5 elephants, is minus 10 elephants. That was a long time on that one page, right? The direct and inverse proportion. F is inversely proportional to the square of the distance. F equals k over d squared. Now let's go over here and find k. When f is 50, d is 2. Don't forget the square because it says the square of d, which is 4, right? 50 times 4 means that k is 200. So f equals 200 divided by d squared. Yeah, as I always say, this is your final answer here. all we do is we try and find what k is and stick it in there instead of k. Find f when the distance is 10. Okay, well, f would be equal to 200 divided by 10 squared. 10 squared is 100. 200 divided by 100 is 2. Or find d when f is 8. Bit harder, right? If you've got this, guys, these two can swap places. The d squared can go up as a times, then the f can come down as a divide. So what I'm going to do this is I'm going to swap those over, and instead of writing f there, we're told that f is 8, okay? 200 divided by 8, oh, not the best, right? But it is 25. D squared is 25, so d is the square root of 25, which is 5. Right. If we get a three-parter, A, B, C, right, the middle part is the important bit. Can I solve this? Can I solve my quadratic? To solve a quadratic, it must equal 0. So unlike linears earlier, where we had letters one side, numbers the other, this is x squared, x's numbers, equals 0. Okay, right. I'm going to do B first here, right? And then I'll go back and see if I can do the show that bit. So a quadratic with a number before the x squared, okay, 4x, because it's 4x squared, and another 4x. Okay, looking for two numbers that will times to make the end, which is minus 7. But when there's a number before the x squared, that end has to times by 4. So actually, I'm aiming for minus 28. What doesn't change is I'm adding or taking away to make the middle, and please, please, please get the sign on that one right, minus 12. I don't care about the minus here, I care about this one, right? So 28 is 1 times 28, 2 times 14, whatever it is. So 2 times 14 seems to work though, to make minus 12. 2 take away 14, plus 2 take away 14. I think I'm doing that right here. Okay. Can I divide these brackets by anything? Yes, I could divide that one by 2, and I could divide that one by 2, actually. So my final answer here is 2x plus 1, because I've halved that, and 2x minus 7 equals 0. So now let's get into the bit we actually are meant to do. We factorize, now we solve. So we've got to bear that in mind, right? A solving a quadratic in paper 1 means factorize, okay? So either 2x plus 1 equals 0. So x equals minus 1 divided by 2. Or 2x minus 7 equals 0. So x equals positive 7 divided by 2. Interpret. This is a question about a shape, right? A square with sides here. It is impossible to have a negative length of x, right? So in a shape question, even though there are two answers that work, the answer to C would be positive x answer is correct. Or words to say something like, we can't use a minus answer because it's a shape and we can't have minus length, anything like that. Right, the show bit I will do, right? But the show bit could be 1,000,001 different things if they go down this route, okay? It depends whether they're talking about a square, triangle, angles, could be linked to circle theory, it could be linked to blinking anything, right? We have to use the information in the question to see if we can make this formula. What we're told, a square has sides of length this and an area of 16. Well, how do I work out the area of a square? Length times width. So length, 2x minus 3, and because it's a square, the width is also 2x minus 3. So length times width equals, and we're told the answer is 16. Expand the double brackets, you get 4x squared, and I'm jumping here, guys, right? I've expanded and simplifying in my head, so I'm jumping ahead a little bit here in terms of steps, okay? That's what you'd end up with, which you can see is very, very close to this. But for a quadratic, we need it equal to 0, not equal to 16. So the 16 would need to go over as minus 16. And if you take 16 away from 9, you get minus 7. So that's a little bit of maths that has shown this quadratic to be correct. That is not the important bit. B is the important bit. Okay, B is the bit to revise. Right, again, because I did this today, right, a minus outside is a reflect up and down. So that would go down to 4 minus 1. It would be down here, it would reflect downwards. Plus 4 is up 4, so it would still be 4 across, but it would go up to 5. A minus inside the bracket is a reflect left and right. So this would reflect over here and would be minus 4, 1. And plus 5 in the bracket is the weird one because it's left 5. And if I move it left 5, it goes down to minus 1, 1. And now that we did one of these earlier, but this time it's higher, we can't have a fraction. Put that in brackets and move it up here. Okay? It's now really similar to the one we did earlier, intermediate. Expand the bracket. Yx minus 8y, or y8, I prefer 8y, equals x plus 3. The difference between this one and earlier is I've got two terms with my subject in. I've got this one and this one, both with x in. That needs to come over this side. Anything without the subject can go the other side. So yx minus x equals 3 plus 8y. And at higher tier, you will have to factorize. Take the x outside a bracket, and I'm left with y minus, and some people are like, well, there's nothing there, but actually, x is 1x, so I'd be left with y minus 1. So x equals, we now do the opposite of what we did at the start. At the start, we moved that up there to expand the bracket. Now we're going to take the bracket that we've got back down underneath. And that's it for that. Right, I've done one example of solving quadratics, haven't I? I've done one here, okay? Another way that may present itself is in algebraic fractions, right? This is such a long video, I'm so sorry. Okay, again, we can't, to solve anything, we can't have a fraction. I keep saying it, whether it's rearranging formula, whatever it is, that needs to go up there as a times, but because I've already got two things up there, that should go in a bracket as well, and then times by that bracket. Again, I'm going to do FOIL, but I'm going to jump a step, if that's okay. So I'm going to end up with 6m and 9. This is a quadratic equation to solve, but I can't have it equal to 25. I need it equal to 0 to solve it. So the 25, like earlier, needs to come over and take away from the plus 9 to give minus 16, 9 take away 25. Okay, this is a nice easy quadratic one because it hasn't got a number there. So two numbers that times to make the end, that add or take away to make the middle. 6. I'm going for 2 times 8, and I'm going for plus 6 to be 8 minus 2. So plus 8 minus 2 equals 0. So m equals minus 8, or m equals 2. Remember, when the plus 8 goes over the, right, again, I haven't done that in full. So that's another way they could give you a quadratic to solve, is to write it like this. This is above and beyond anything I'd hope that you get. Here, there's 2 fractions, not 1. And then something on the other side. So before we even start, we need to make the 2 fractions into 1. We need to express 2 fractions as 1, which is sometimes a question in its own right. Express 2 fractions as 1. So the top of that one times the bottom of that one, plus the top of that one times the bottom of that one, divided by the bottom of that one, and look, I can always put things in brackets if there's 2 things, right, when we're doing these, times the bottom of that one equals 3. Guys, plod on, come on. I'm just going to jump steps, okay, so I'm going to end up with 14x there and 10x there, so that's going to be 24x in total. You can do this again, slow it down. Minus 35 plus 20 is minus 15. On the bottom, FOIL 2x squared minus 1x, if you work it out, okay, minus 10, just you do that, take your time and do it, equals 3. It looks a bit more now like that, just a little bit more complicated. The bottom now can come up as a times. That can come up here and be written here. Again, I'm jumping steps because I haven't got a lot of space. So I'm doing this all on kind of one line here, okay? 24x minus 15 equals 6x squared minus 3x minus 30. So I've timed all those things by that 3. But if I see a quadratic, I can't have it, like I said earlier, I can't have it equal to this. I need it equal to 0. So both these things need to go over. The 24x will take away from the 3x to make minus 27x. The minus 15 will add on to the minus 30 to give minus 15. Okay? Now you've got yourself a quadratic that can be solved. Right? Do I want to do this? No, I'll start you off. 6x, this is what we need to practice, is these, okay? Go on Corbett if you want to do some more of these harder quadratics. Two numbers that times to make the end, but the end needs to multiply by 6, so I'm aiming for 90. The add or take away to make the middle is minus 27. The only sum that comes to mind for 90 is 3 times 30, which works here, okay? 3 take away 30 will give you that. Divide this by 3, divide this by 6, because 6 goes into both of those. So we end up, and I'm jumping all over the place like I said, right, so we end up with 2x plus 1, and then x minus 5. So my two answers are minus 1 divided by 2, or 3. Is that 3 or is that 5? Can't remember. 5, and oh gosh, so that's 5, or 5. That's minus 5 there. Right, that's heckish hard, we would say, okay? But just have a look at those and see, right? They're likely to be quadratic ones, but you've got to do a bit of work to get them looking as you want. Okay, we've got to draw these 3 lines and colour in the triangle. Let's start with the easy one, right? We're going to draw y equals 1. Y equals 1 is there. For this one, we're going to draw y equals x. So when y is 1, x is 1. When y is 2, x is 2. When y is 3, x is 3. It's unusual because the scale's all out. I've got the x going up in 1s and the y going up in 2s, so it's a bit of a funny looking line this, but it's terrible, but you get the idea. Just use a ruler. This one, y equals 4, right? I'll take the x over to make it easier to work with, and I'm going to draw a little table with x values and y values. So x values, I'm going to take just 0, 1 and 2, because they're the first ones I can see there, 0 and 2. I could also do 3 and 4, but we don't need lots of points. So 4 take away 0 is 4. 4 take away 1 is 3. 4 take away 2 is 2. So it's 0, 4, 1, 3, 2, 2, which is there. So it's coming down, this one is like that. And the triangle that the 3 line makes is there, and that can be shaded in. Congruence. Okay, three conditions for congruence. SSS, 3 sides equal. SAS, 2 sides equal and the angle between them. Or ASA, 2 angles equal and the side between them. By congruent, I mean identical. So here, I've got a 14 on triangle A, which I can also see on B. I've got a 10, which I can also see on B. And importantly, 25 is between the 10 and the 14. So the condition here is side, angle, side. Here, 3 sides the same on both, side, side, side. And on here, O. Angle, angle are the same 2 angles on here, but I don't know what that's, I don't know that those sides are equal, so I can't write ASA because the side that I know isn't between the angles. But the one here is if you know 2 angles, you can actually work out the third. So the third angle here is 75, and the third angle here is 75. So actually I have got angle, side, angle, angle, side, angle. So it's A, S, A. So you're looking to write one of those. Sometimes they'll give you A, right? And ask, so three angles the same, right? And ask, are they congruent? And the answer is maybe, right? However, all three angles tells you is that they're similar. One might be a bigger version than the other. So they're similar, they may be congruent, they may be the same, but AAA doesn't prove they're congruent, whereas SSS, SAS, and ASA do prove they're congruent. You might have to pick out which condition it is, and you might have to do a little bit of work in it. You probably have to look at the booklet that I've done for that, okay? Trigonometry graph, draw the cos graph. Sine graph starts at 0, goes up to 1, back, down, up. Cos graph starts at 1, don't make it almost like a straight line, but a slight curve to it. Again, slight curve, slight curve, slight curve. One solution to 0.7 is x equals 40. So what they're trying to tell you here is when that's 40, one of the solutions here is 0.766. I like to write, though, 40 there and then work out what that is, which is 50. So work out the split there. Okay, they are then asking for the answer, the other solution for 0.766. So the other solution for 0.766 is over here, but we need to know which, which is 40, which is 50. Okay, before I do that though, no, I am going to do that. Okay, it would go 40, 50. In this section, it would be 50, 40. In this section, it would be 40, 50. And in this section, it would be 50, 40. So it's kind of like the mirror of what has happened here. 40, 50 over here, and then 50, 40 over here. So the other answer to this is 320. It is far more common, though, guys, to be asked for the answers to minus 0.766. Which would then be this one and this one. 40, 50, 50, 40, 40, 50, 50, 40. So you've got perfect symmetry in the middle. So the two answers to the solutions for minus 0.766 would be 140 and 220. Okay, that is far more common to be given one of the positive solutions and then asked for the two negative solutions. Okay, use your sketch to work out the value of cos 200. What? I'm not quite sure how you can. No idea. That's bad, isn't it? Because 200 is there, right? So we can kind of see it's roughly what it is. It's sort of lower than that. It's about minus 0.8, minus 0.9. Yeah, don't know. I think that's a bad question. Ignore that. Oops. Okay. Enlargement. In higher tier. Scale factor minus 2, use it in 0.6 as the centre. Minus 2, twice as far away in the other direction. So to get to this point, it's 2 left, 2 up. Twice as far in the other direction would be 4 right, 4 down. To get to this point, it's 4 left, 1 up. Twice as far in the other direction would be 8 and 2 down. To get to this point up here, it's 2, 1, 2, 3, 4. Twice as far in the opposite direction would be 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then hopefully you could see that that point's going to go down there, but you could count it out. So my new shape here, when I connect it up with a ruler, is twice as far away in the other direction. Looks like it's rotated. If they were drawn, though, remember to find where X is, you'd have to draw those lines in. And you could then find where X is. Oh, that is so bad. Okay, but you get the idea. Right, I haven't done a lot of this, have we? Right? If we get this, we've got to go to the front of the book and copy out what we need. First of all, is the question about surface area or volume. This one is the surface area of the cone. If you look in the front of the formula sheet, the curved surface area of a cone is pi times r times L, where this length here is L. Okay? Right? But that is just the area of the curvy bit, the round bit of the hat. There is another surface at the bottom, which is a circle. So if I was covering this with wrapping paper, not only would I wrap up the curved bit, but I'd also have to wrap the bottom, which is a circle, which has an area of pi r squared. Okay? We know the radius is 4 though, so I can put 4 in there, and I can also put 4 in there, right? What I don't know is L, or Y as they called it, which is what this question is asking me to work out. What's Y? What they will tend to do in this question is give you what the total answer is, what the total volume is, or what the total surface area is. So in this case, these add up to that. And it's really important in non-calculator that they leave pi there. Because in non-calculator, what you'll find is all of your formulas, circles, cones, spheres, everything, all of them have pi in. So you now don't need to times by pi because everything has got pi in. So what we can do is, in these questions, is cancel pi. So what are we left with? We're left with 4L plus 4 squared, which is 16, equals 48. And we've got to find L. Well, the plus 16 will take away from there, leaving 4L equals 32. So L is 32 divided by 4, and 4 does go into 32, so we can do this. If it didn't, we just leave it like that. So it's 8 centimetres. I think we're getting there. My apologies. Okay, how many discs are we taking? Right, conditional probability, so without replacement. One disc is taken around from the bag, the disc is not replaced, another disc, so we're only taking 2. Okay, so we're taking 2. So this is going to be something times something, and or I'm going to list my combinations. So calculate the probability that exactly one M is taken. Right. If this is a question about M's, then every other letter is not M. If this was red and blue and yellow, and it was a question about red, then everything else becomes not red. So in this case, I have 2 M's, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 not M's. In order to take 1 M from the bag, my combinations are either take an M followed by, because I'm taking 2, remember, not an M, or start with not an M, and on your second take an M. So the probability of this is 2 out of 11 times, how many of them are not M? Did we say 9? But if we've taken an M first time, there's only 10 left. So that's 18 out of 110. On the flip, the chances of not getting an M is 9 over 11. But if I take a letter that's not an M, be it the A or the H or whatever, then I now have 2 M's still left, but out of 10. So again, that is 18 out of 110. Right? If you listed all the combinations separately and didn't group them into not M, you'd have to go MA, AM, MT, TM, MH, HM, ME, E. You get the idea. Grouping things makes this a lot easier. And because I'm allowing this combination or this combination, I need to add the answers together, which is 36 out of, and do not add the bottom numbers, only add the tops. Right, construction we did today, I'm really going to belt through this, okay? So, AB would probably be drawn for you in the exam, is 8 centimetres. I want angle B to be 60, so here, I want line there, from stabby bit there, and connect that to there, there's your 60. I want angle A to be 45, can't draw 45, can only draw 90s. Okay. Measure a couple of centimetres that way, measure the same distance that way. Almost picture this as a new line. Use these for your stabby bits here and here. What you'll get from there is you'll get bum, bum from this stabby bit, and bum, bum from this stabby bit. And instead of connecting sideways like you do for a 60, we connect straight down through the A, lovely jubbly. Okay? One of these, the 90 needs to be halved. sometimes it's the 60 that's half, sometimes it's the 90. To half it, again, now don't put your stabby point here, put your stabby point here, and you need a little circle. It doesn't matter how far you open your compass, just don't open it too far. Get these two really important points here and here. From here, get that line, from here, get that line, and take that up through there. And you've now split that 60 into 30, 30. Keep that line going, and where it meets this line, that must be where point C is. So you've now drawn a triangle ABC. Same here, but instead of halving the 90, half the 30. So where the 60 is over here, right, little one of those, get your two important points, then you've got there, there, connect. And it's 30, 30. Oh, I was wrong in the last one, wasn't I? Dear me. That was a 90, we halved the 90, so that's 45. Oops, I'm not going back to re-record because of that. Okay, if it's at a random, if it wants, right, what words it uses? Words the word perpendicular. Perpendicular means 90 degrees. So we're drawing a 90-degree angle, right? So we need this to come straight down, but we can't just use a ruler here, okay? So if you wanted at a random point, rather than drawing 90 here or here, which would be easier, okay, put your stabby bit here and open your compass to here. And start drawing a circle through here, but also give me the bottom of the circle. Then put your stabby bit here and open your compass to here again and start drawing a circle this way and do here. And where they cross, come down, and that's 90, and the final page. Exterior angles add up to 360. You can either divide that by the number of sides to get the exterior angle, or you can divide 360 by the exterior angle to get the number of sides. In this case, it's regular, which is what we need, means all of them are the same, all the angles are the same. So if the exterior angles are 45, how many 45s go into 360? There's 8, so this must be an 8-sided shape. And the final construction is this, but a few of you got a bit, right? We've got to draw this beneath using compasses and rulers. So I'd start by drawing this line, 7 centimeters, okay? And here, because I'm drawing a 45 at B, I'm going to need to construct a 90. So artificially make a line 2 centimeters, 3 centimeters either side. Boom, 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 boom. Okay, but you do this beneath, not here. There's your 90. But this time you can actually keep your dot. You can draw a dotted line here. And rather than draw the 45 in this direction, right, which we used to, we're drawing it this direction. So stabby bit there, open up, get your two important cut points, and then from there you'll get this, and from there you'll get this, which will allow you to locate that and draw your 45 that way. So it's a bit like what we did. We're drawing the 90 at the end of the line, but then the 45 is going away from the triangle rather than inwards. Okay? And that's that. Hurrah! All the best, everybody. Right, give me a shout on Teams for anything else you want. If you think there's something I haven't quite explained or you want more help with, let me know. If you're happy with everything, maybe go on to the link in Teams to DIY Maths and have a look at a couple of paper 1 past papers. Right, maybe ones you haven't done that are a bit older, 2016, 2017, 18, I don't know, whatever, okay? Any problems, let me know, and I'll see you Monday.